Okay, in the following example, we are going to be looking at derivatives of inverse trigonometric functions, and we're just going to stick with a couple of basic ones. Once you figure out these two basic ones, the rest follow basically the same rules. So when you see these couple of examples, you could tackle any of the other ones. I mean, I think just as easily. Okay, so what we're going to make note of, first of all, is that we've got these various rules here for sine and cosine. All right. One thing that I'll point out is kind of do note where one may be positive or negative, and I think that once you do that, you'll kind of see, there's a negative, there's a negative, there's a negative. Typically, any of the original function that starts with a c, your derivative is going to be negative. Okay, so kind of keep that in mind. But other than that, I mean, let's go ahead and just apply the rules, and we'll get into it. So just want to point out here that this is u. So if we need to know, for example, a u prime, well, we'll just take the derivative real quick before we get going. So 3x squared minus 2, the derivative is going to be 6x. Okay, so keep that in mind. Now let's apply the rule for cosine inverse. The rule for cosine inverse says that you take negative 1 over, okay, give me 1 second. You get negative 1, so y prime equals negative 1, and I really don't need to write negative 1, I'll just put a negative in the front. And then on the top, you have 1 over the square root of 1 minus u. So in this case, u is 3x squared minus 2, okay? And then du dx, which is our u prime, which is times 6x. So that's why we found it already earlier. All right. Other than this, okay. Oh, and by the way, the u is squared in the denominator. I almost missed that. Okay. So other than that, it's just a simple matter of cleaning it up a little bit. Negative 6x over the square root of 1 minus 3x squared minus 2 square, something like that. And it's not much to it. I mean, we just basically plug in. Okay, the derivative part's really easy. All right, you just kind of follow the formula, if you will. So let's slide this problem up just a little bit. In this case, this one looks a little bit more challenging just because of this weird looking u here. But I'm going to tell you that it's, if you think about it, I'm going to write it out here. U equal 6 over 5x plus 3 over 5. It's basically a linear looking function there. Okay, so if we were to find u prime, it's just this right here, 6 over 5. All right, there's nothing to it. It's actually really, really simple. Okay, so now we're ready to apply the rule for sine, which is to say that we take for y prime 1 over the square root of 1 minus u squared. So 1 over square root of 1 minus, and then it's 6x plus 3 over 5 square times u prime, or du dx. U prime in this case we found was 6 over 5. And there's not much to do to clean it up. I mean, you can clean it up just a bit. So let's go ahead and try that out. You end up with something like this, 6 over 5 times the square root of 1 minus, and I'm going to leave the 6 plus 3 on the top squared. I'm going to multiply this by, or I'm going to square the denominator rather, 25. And that's actually going to give me something kind of interesting, because I could actually pull this 5 back in here. I really could. And if I do that, that's actually going to get rid of the 25 down there. Watch. You square the 5 and you can put it under the square root, because 5 squared is 25 and the square root of 25 is 5. So that's the way kind of that it works. And so we can do that because it'll help us clear the fraction, and it works out so nicely in this case. So we end up with, when we pull that 5 back in, the square root, suppose, of 25 minus, and then it's just going to be 6x plus 3 quantity squared. Okay, could you simplify that? Yeah, you could, but I think it's safe just to leave like this. Okay, because when you think about this, and just to go back, because you're probably wondering again what happened to that 25. When you pull the 5 back in, it's going to be basically a 25 on the inside, but you have to multiply it by everything. So the 25 gets multiplied by 1 there, and it gets multiplied by this fraction, but coincidentally what happens is that the 25 ends up crossing out through that multiplication and leaves you with this 6x plus 3 square. So that's basically it. Once you finish cleaning it up, this is what your derivative looks like. And there's not much to it. I mean, like I said, once you figure out one of the rules, you'll figure out the rest of them. They're pretty intuitive and you can apply them. So I hope this video was helpful. And as always, like and subscribe.